Okay, guys, in this problem, the position versus time function is given 5t squared minus 4t cubed, and they want the velocity, the acceleration as a function of time, the value of the velocity and the acceleration 2 seconds later, and at what time the position is maximum, the time at which the velocity is 0, and E the maximum position. Now pause the video and try to solve. So this is the problem. This is what is given. Find the velocity as a function of time, the acceleration as a function of time, the velocity at 2 seconds, the acceleration at 2 seconds, the time when x is maximum, the time when the velocity is 0, and what is the maximum value of x. So let's find the derivative. So a is just b is dx dt, which is 10t. So the 2 goes to the front. So 2 times 5 is 10. And 2 minus 1 is 1. So it's just t. Minus the 3 goes to the front. 3 times 4 is 12. And 3 minus 1 is 2. So that's the velocity as a function of time. The acceleration as a function of time, you just take the derivative of this. The derivative of 10t is just 10 because it's 1 minus 1 is 0. And this is 24, 2 to the front, t. Okay, that's part A. Part B is just find the numerical value. What is the velocity 2 seconds later? So you just need to do 10 times 2 minus 12 times 2 squared. So it's 20 minus 48, which is negative 28 meters per second. And the acceleration 2 seconds later is 10 minus 24 times 2, which is 10 minus 48, which is 58 meters per second squared. I didn't put seconds over here to put seconds. I think this is negative 38 meters per second squared. This one over here. So C, when the position is maximum. You know the position is maximum or minimum, max or mean, when the first derivative is 0. Well, what is the first derivative? The first derivative is the velocity versus time is 0. So if we have this equation over here, 10t minus 12t squared equals 0, because that's what the velocity is, 10t minus 12t squared. And we take 2 as a common factor, 2t, and I get 5t minus 6t equals 0. So I get at time 0, or it doesn't go here. Is if you take t as a common factor is 5 minus 6t, or 5 minus 6t equals 0. And t is 5 over 6 seconds. Now this is the one that looks reasonable. Now, how you know it's a maximum and not a minimum? You need to take the second derivative. The second derivative, which is the acceleration at this time, and it has to be negative in order to be a maximum. So check that out. So check that the second derivative at this time is negative. Now that is the time, that's number C. And you just need to check that is maximum at that value. So this is 10 minus 24t, and this is 5 over 6, and that gives negative 10, which is 0. So this is a maximum. If the second derivative is positive, then at that time is occurring a minimum. What they're asking for this time. At time zero it has a maximum. It has at time zero, the second derivative is at time zero. You have 10 minus 24 times 0, because this is the other case. You get positive 10 is minus 0, so it's a minimum. So at time 0, this is a minimum, and at this time is a maximum. Again, to recap, the maximum or minimum happens when the first derivative is 0, and the first derivative of the position is the velocity, so that happens when the velocity is 0. So you set this equation 10t minus 12t squared equal to 0. Take 2t as a common factor, so you get 5 minus 6t. So t is 0, or 5 minus 6t 0, which gives 5 over 6 seconds. And then check the second derivative, the acceleration, 10 minus 24t. You evaluate the acceleration at those times. If the acceleration is negative, is a maximum. If the acceleration is positive, is a minimum. So the maximum, that's what they're asking, is at 5 over 6 seconds later. Now, D is asking at what time is the velocity at what time is the velocity 0, and this is what we did on C. At t equals 0, or t equals 5 over 6 seconds. And E, what is the maximum? So you know it happens at 5.6, but what is the maximum? How many meters? So you just use x of t and you evaluate at that time at 5 over 6. 5 times, I will put parentheses, 5 over 6, close parentheses, square, okay, minus 4 times parentheses, 5 over 6, close parentheses, cube. And this is 125 over 108 seconds, which is 1.15741 seconds. So this is the time. I mean, this is meters. This is seconds, and this is meters. So 1.15 meters above. So the maximum position is 1.16. We have those. They didn't ask for that, but it's fun to do. We are going to graph the function. Remember that physically speaking, time goes from 0 to infinity. From 0 to minus infinity, it doesn't make sense physically speaking. So this is x of t. Okay, we know the maximum was the maximum was 125 over 108 meters. That is 1.16 approximately. That's the maximum. So, but we know that this TQ squared is what we're going to graph it, and this is the term that makes sense when time is big or when time is very small. So you know the function is coming from here, then something happened here, and then here, because this is minus t cubed. You know that's the shape of minus t cubed, and that is the term that this part doesn't happen in reality. Time cannot be negative, but you know it's coming from here, so it has a minimum here, because you know the velocity is 0 at 0, and then does this, and then like that. And this is the maximum that happens at 5 over 6, which, and how I know this 0? What is this point and this point? That's easy, because it's just taking t2 common factor, 5 minus 4t, so t0 and t equals 5 over 4. So this is 5 over 4. And you know that the velocity, if you look at the equation for the velocity, it was 10t minus 12t squared. So I can take 2t, so 5 minus 6t. You know that the velocity at 0 is 0, so the slope over here is 0. And I told you it's a minimum. Because the derivative of the velocity, which is the acceleration, at 0 is 10. So this is a minimum. And this is the maximum that the problem was asking about, is when t from here, when t is 5 over 6 seconds, is a maximum. We know it's a maximum because the first derivative of the velocity, which is the acceleration at 5 over 6, we got negative 10, which is negative. So we know it's a maximum. So what do you think happens over here? This over here is what is called an inflection point. It goes from concave to convex. This is an inflection point. And you find the inflection point, if you want to know where this inflection point, there is nothing else over here. But we don't care about this. Time is never negative. What is an inflection point? Inflection point is when the velocity, the derivative of the velocity is 0. That means when the acceleration is 0. And the acceleration is 10 minus 24t, so at t equals 10 over 24 or 5 over 12. So half this, 5 over 6, half that is over here, 5 over 12. Is an inflection point, go from concave to convex. And this is the graph of the function. One inflection point, one maximum, and 2 zeros. So if you want to try to recreate this motion, this is position. So the object moves forward, and then the acceleration starts being negative and goes backwards all the way to infinity. And when the acceleration goes from positive to negative is at this inflection point.